Welcome, wherever you are. Let me take you through MARANDA post-mock chemistry paper 2. Let's look at the question they predicted. The first question is from the periodic table in a chemical family and even bonding. Remember, that question is a must. Study the ionization energy of calcium below. So we have first ionization energy and second ionization energy. As you can see, second ionization energy is always higher than that of the first. So first define ionization energy. Ionization energy is the minimum amount of energy required to remove an electron or electrons from the outermost energy level of an element in gaseous state. Minimum amount of energy required to remove an electron from an atom in gaseous state. Explain why the second ionization energy in calcium is almost double the first one. It is because after removing the first electrons, the remaining electrons are held more firmly by the positive nuclear charge, which require more energy to remove. Study the table here and answer the question that follow. We have sodium, aluminium, then the chloride. Sodium chloride, aluminium chloride. So first, I want to remind you that aluminium chloride is the only chloride that is very unique among all the chlorides. While sodium chloride is an ionic compound, aluminium chloride is not an ionic compound. In fact, it is a molecular compound or is a molecular substance. So it is very unique. Remember, when sodium chloride is forming an ionic bond, this one forms dative. That is covalent and dative combined. You see that? So that is the uniqueness. Let's look at the questions. Explain why the melting point of sodium chloride is higher than that of aluminium chloride, yet both of them belong to period 3 chlorides. The reason is simple. This one is an ionic compound and this one is a molecular compound. Very, very important to note. Sodium chloride has a strong ionic bond in the giant ionic structure, while aluminium chloride has a simple molecular structure with weak van der Waals forces, which require very little energy to break. Other than the properties given in the table above, give 2 reasons why aluminium is used in making cooking pots. So one of the reasons we can see here, it is a good conductor of electricity. You can see good conductor of electricity and heat. It is a good conductor of electricity and heat. So apart from that, it is resistant to corrosion. It is also light. State and explain the observation made when a blue litmus paper is dipped into a solution of aluminium chloride. So as I said, aluminium chloride is unique. It hydrolyzes in water to form hydrochloric acid. So if you dip a blue litmus paper, then it will change to red. Blue litmus paper changes to red. Aluminium chloride hydrolyzes in water to form hydrochloric acid solution. Use dots and a cross to represent electrons and the bonding of sodium chloride. So sodium being an ionic compound, there is complete transfer of electrons from sodium ion to chloride ion. So this is what happens. The sodium will lose the outermost energy level, and that electron, the X you are seeing here, this is how you should draw it. Sodium and chlorine have the same valence. Compare with a reason their ionic radius. In other words, they are saying we compare the ionic and the ionic radius. Sodium and chlorine have the same valence, yes. Compare with a reason their ionic radius. So of course, the ionic radius of chlorine is bigger than that of sodium chloride. Yes, the ionic radius of sodium is smaller when you compare with that of chlorine. Very important. The ionic radius of chlorine is larger than that of sodium ion. The chloride ion has a more number of occupied energy levels, except the use of nuclear repulsion. If you understand how to use that, we as well accept your answer. Electrolysis of copper 2 solution. What is electrolysis? It is a very good thing. You need to remember how to define electrolysis. The decomposition of an electrolyte process by passing it through a current, by passing electric current through it, and get decomposed by it. So that is the definition of that. Label the anode and the cathode. Label the anode and the cathode. Gas P. There is a gas collected here. So this is the cathode and this is the anode. So this is the cathode and this is the anode where we have gas P. What is electrolysis? We have defined that. Label the anode and the cathode. So I've told you that the cathode is on the left, the right side. That is where my cursor is. This is the cathode and this is the anode. Explain how you would confirm the gas P. So which gas is P? In this reaction, electrolysis, the copper 2 oxide solution, oxygen is going to be discharged, hydroxide ions, OH negative, is going to be discharged. It is going to be preferentially discharged. Therefore, gas P is oxygen. So oxygen, if gas B is oxygen, then introduce a growing sprint. The growing sprint rekindles. State 2 changes that occur on the electrolyte after the experiment. What would happen? Because hydroxide ions has been discharged, the pH reduces due to the presence of uncharged HCl. The pH reduces. The blue color of the electrolyte fades. Use the standard this one. State whether acidified this can oxidize M positive. Give reason for your answer. You can see manganese ion here. It is positive 1.44 and M3 is 0.7. So the question is, state whether this one is going to oxidize. This is more of oxidizing. Yes, it will oxidize this. It's going to oxidize. Yes, it is going to oxidize because the EMF is more positive. So the manganate ions here is more positive, therefore it's going to oxidize this one. Write the E theta of the half cell of A if P was used as a reference electrode. P A. Select two half cells which will produce the highest. So those that will produce the highest is the most negative and the most positive. So you check the most positive and the most negative. When you combine them, they will give you the highest EMF. So you just check here which one is the most positive and the most negative. When the two are combined, so that's P and T. When they are combined, they will give us the most. The half cell of element T and the P will give us the highest EMF. Select two half cells which will produce the highest. We have done that. Is it possible to store a solution of A in a container made of B? Show you're working. So you need to work out and see if it is positive or negative. So if it is positive, like this one is positive, it will not react. It will react. The E theta is positive. No, they will react. So you cannot store. If the EMF is negative, then they will not react. But now, since when you calculate the EMF for the two half cells, then it means it is positive here. It means the solution cannot be stored in container of P because it is going to react with it. So is it possible to store a solution A in container B? No, because they will react. The E theta is positive. Draw a well-labeled diagram. Electrochemical cell when a half cell named above is combined. So this is the cell. We should have the salt bridge. Name the electrode properly and you will score that mark. So electrochemistry will never miss in an exam. Be aware of that. Hydrogen, nitrogen, compressor, catalytic chamber, oxygen, compound nitric. So now you can see there is a combination of HAPA process and the manufacture of nitric postward process. So that it has been combined here. Even they have included sulfur. You can see here. State the optimum conditions for temperature required in step 1. So let's step 1. Compress that to, so step 1 in the catalytic chamber is the temperature of 450. Reject the range. If you write this range, it will be rejected. Just write a temperature of 450. Name the catalyst used in the catalytic chamber. It is finally divided ion 2. Ion, not ion 2. Ion catalyst is used as a catalyst in the HAPA process. Because ammonia, hydrogen and nitrogen and hydrogen, it is the HAPA process, the first one. Step A. Now step A, we are coming here. The catalyst used is platinum, rhodium. Platinum, rhodium is the catalyst used in the manufacture of nitric acid. Identify R, oxygen plus the catalyst, then Roman 2, R. What is that is missing there? It is water. Write the two chemical equations taking place in step A. Step A is now where ammonia combines with oxygen plus the catalyst to form this reaction here. Nitrogen 2 plus this. Then nitrogen 2 reacts with this to form nitric acid. Identify the process taking place in step B. Step B, nitric acid plus this potassium nitrate neutralization reaction. Step E, where is step E? Sulfur plus step E, then gas Y and gas Z oxidation. Conc sulfuric acid acts as an oxidizing agent here. Explain how the reaction in step C occurs. So nitrogen, being a strong oxidizing agent, it oxidizes hydrogen sulfide to sulfur. Give the possible identity of substance D. It can be N of this T. T can be N of those. Write the formula for the compound P and give one of its uses. Compound P. P, where is P? Now nitric acid plus ammonia gas, it forms ammonium nitrate, and that is a fertilizer. Then you should know the fertilizer, the uses of ammonium nitrate fertilizer. It is used as a nitrogenous fertilizer, manufacture of explosives, for preparation of nitrogen to nitrogen 1 oxide in the lab. Chemical reaction occur as a result of collision particle. Give reason for the collision. Now we are in what we call lack of minimum activation energy, lack of proper orientation of particles, and can do. State then explain how the following factors affect the rate of chemical reaction. Increase in temperature. So we are in reaction rates. How does temperature increase affect the rate of reaction? Decrease in concentration. How does it affect? Decrease in concentration decreases the number of reacting particles, leading to decrease in the number of effective collisions, hence decrease in the rate of reaction. So there is a graph here. Describe the procedure of determining the rate of reaction at 12 minutes. Draw a tangent at 12 minutes. Determine the gradient. The gradient is the rate of reaction. How does the production of oxygen in region AB compare with that of BC? AB, and BC. So the rate at AB is very high. The rate of AB is lower than BC. The catalyst added at B, which increases the rate of reaction. State the Rajdel's principle. When a change in a condition is applied to a system at equilibrium, the system moves in such a direction so as to oppose the change. State and explain the observation made when few drops of potassium hydroxide is added to a system at equilibrium. The intensity of the white color increases. Adding of potassium hydroxide lowers the concentration of the HCl, thus favors forward reaction. Write the following reactions. Sodium metal reacts with pure ethanol. So we have entered organic chem. State the meaning of each of the following. Saponification, a process of hydrolyzing fats with alkali in the presence of heat to form soaps. Salting out, adding sodium chloride to a soap mixture to precipitate soap. Write a general chemical formula for soapless detergent, and that is it. That is a soapless detergent. Soapless detergent should have a sulfonate, SO3 in this one. Without this one, you will not score. Briefly explain how soapless detergent removes grease particle during washing. During washing, the hydrophilic end, polar end that is dissolves in water, while the hydrophobic non-polar dissolve in grease. Agitation then takes place, making grease to dislodge when the cloth is rinsed. State one advantage and one disadvantage of soapless detergent. Advantage does not form scum with hard water. A disadvantage, that's the advantage. Disadvantage, it is expensive and non-biodegradable. The polymerization of tetrachloroethane is similar to that of ethene. What is meant by the term polymerization? Process by which small molecules, that is the monomers, combine to form large molecules called polymers. Draw the structure of the polymer from the monomer. That is it. State N2 advantages and that the synthetic polymers have over natural polymers. These are the advantages of synthetic over natural polymers. Energy changes. I don't know whether it is feasible. This is the number 6 is the energy changes. What do you understand by the term molar heat of combustion? Molar heat of combustion. It is the enthalpy change that occurs when 1 mole of a substance is completely burnt in oxygen. During an experiment, the data given below is recorded. This is the data. So we have the volume of water, 500, initial, final, and initial temperature, final mass, or those, density of water, and the specific heat capacity. Calculate the temperature change. So temperature change, it is the final minus initial, that is 27 minus 20. The temperature change is 7. The final, calculate the mass of methanol. It is the final mass minus the initial. Calculate the molar enthalpy change. Remember, this is what you do. That is, remember, the enthalpy change is equal to mass times specific heat capacity times temperature change. So the mass of water here, this is 500 centimeters cube, is the same as 500 grams. So you divide by 100 to make it into kilograms, because the specific capacity, when you look at it here, it is given in kilograms. That's why you need to convert 500 grams to kilograms by dividing by 1,000. So this is the heat change. But you are asked to calculate the molar enthalpies, molar heat. So you get the number. This moles was able to produce. So the final, it is negative 54.44 kilojoules per mole. So there's a difference between heat change and molar enthalpy. Therefore, you'll be aware of that. Thermochemical equation, and that is the thermochemical equation. Draw the energy level diagram to represent the experiment above. This is what is expected. What is heat value of a fuel? It is the amount of heat given out when 1 gram of a fuel is burnt. So question 7 is coming from radioactivity. It is from radioactivity. Identify the charge. The charge of X is negative. Name the radiation represented by C, that is beta, because beta is negative. And X is positive. X is positive. So you need to understand the characteristics of the radiations. That is the beta, the alpha, and the gamma. So expect a graph in paper 2, a graph from either rate of reaction or a graph like this from radioactivity.